We're going to solve this chemical equation. We're going to balance this chemical equation using the algebraic method. First, put in variables A, B, and C, one for each of your chemical species. Your equal sign for a linear equation will appear at your yields or produces arrow. Set up a linear equation for each element type. 2 H's with A, 2 H's with B. So 2A equals 2B. Do the same for oxygen. Then you'll need to set a variable equal to 1 and solve for the rest. A was selected because it immediately tells us about B, and because A and B are both equal, it will allow us to solve for C relatively quickly. Choosing B equal to 1 would have been perfectly acceptable as well. When we solve for C, we find out that C equals 1/2. This means that we'll need to double everything. Some might say, wouldn't it have been best to solve for C equal to 1? That would have required a large amount of substitution, and that could have become challenging. Here is the traditional method. It typically involves a RAP table, reactants, atoms, products table. It's a seesaw method, teeter-totter method, but it's definitely trial and error at some instances. By setting up the table, you get to see what is balanced and what is not, and then make adjustments. With this particular one, it was helpful to try to set or make the oxygens even by adjusting B and then solving for A. Here I'm showing that the RAP table and the linear equations are effectively the same thing. The linear equation requires just to solve using math, where the RAP table or the teeter-totter seesaw trial and error method requires you to think about what you're putting down and come up with reasons for why you're putting it down. This can be troubling at times.